Okay, example 3. The following rational equation has denominators that contain a variable. For this, do the following. A, write the value or values of the variable that make the denominator 0. These are the restrictions of the variable. B, keeping the restrictions in mind, solve the equation. Now, I copied these instructions from MyLab Math in the fall of 19. When you get to the computer, are the instructions going to be the same? I don't know. But come test time, all the instructions are going to say is solve the equation. That's all they're going to say. That in the computer, they have a tendency to give you a little more guidance than I will. Test time, it's just going to say solve, and then you need to think about these other things. So letter A, the values that will make the denominator 0. Denominator, or in this case, denominators, 0. Would be, for x, would be x equals 0. For 5x, that too would be x equals 0. And so these are that's my restriction, that I cannot accept an answer of 0. And then on letter B, with keeping the restrictions in mind, solve the equation. So 4 over x equals 9/5 minus 7x minus 4 over 5x. I'm going to clear my fractions. No equation, no parentheses to clear, so I'm going to clear the fractions. I'm going to multiply all terms by the common denominator, which in this case is 5x. So 5x, and I'll put the 5x on the end there, 5x. So doing my canceling then, the x's cancel, leaving me 20 equals, the 5's cancel, leaving me 9x, and then the 5x's cancel, and very, very importantly, and I'll do this in 2 steps, that minus sign applies to the entire fraction. So very technically and very importantly, there are really parentheses there. Now, if you can remember that it distributes and you don't want to put the parentheses there and go on to the next step, you can. But I'm just putting the parentheses there to very explicitly remind us that that minus sign applies to the entire fraction. So when I cancel the 5x's, that minus sign is still applying to everybody, so I put it in parentheses. Then we will distribute that minus sign. And I'll go on to another piece of paper here. So I get 20 equals 9x minus 7x plus 4. Combine like terms. So 20 equals 2x plus 4. Or that's the same thing as 2x plus 4 equals 20. You can always just flip around an entire equation. It's called the reflexive property, that you can turn it around like that. That's not terribly important though. Subtract the 4. I get 2x equals 16. Divide by the 2. And I get x equal 8, which was not our restriction. So the answer should be 8. If I did all my work correctly, the answer should be 8. Now on the next page I have the steps all, to check it, and we're going to check it the exact same way. We're going to look at a graph and check it, and we hope that that x-intercept is going to be 8. And that's what we're going to see on the next page. I can see ahead. We did good. So there's my answer. And so really on this one, there was no essential difference to the other equations we've done, other than we had to think about that restriction. Now checking it. So checking it graphically, doing the same things. I move everything to one side. And notice I don't have to simplify it. Let's zoom in just a little bit, because that type's a little bit small. I don't have to do any simplifying. I just move everything to one side. So the 9/5 went to the left, it became negative. That entire fraction, which was minus, I move it to the other side. Entire fraction becomes plus. I press my y equals key and I type it in there using careful use of parentheses. So when I get to this last fraction that I have to type in there, the entire numerator in parentheses divided by the entire denominator in parentheses. And in most cases, the standard window zoom 6. Now these are steps for a TI-83, 84. If you have a Casio or Sharp, I'm sure there's similar things you can do. I just don't know how to do it on a Casio or Sharp. Okay, and so then you're going to get a graph like this. I made a calculator, I made a computer graph it, but you get a graph that looks similar to this. Notice this time it's not a linear graph because I had x's in the denominator. So initially it was not linear because those x's in the denominator. Linear functions, linear equations don't have x's in the denominator. But there's my x-intercept right there, x equal 8, x equal 8. Everything looks good. We know it's right. And so again, come test time, you've got a few moments, check these things. You can catch stupid mistakes for you, and you get more points. Now, in general, when I'm grading tests, unless you happen to be in one of the huge classes that has online multiple choice testing, well, there's no partial credit there. But if you're in one of my smaller classes where I actually grade stuff, if I'm actually grading it, I give more partial credit for people that check their work and know they're wrong and tell me. So that you check your work, it's like, yeah, I got 12, I can't find my mistakes. So you write me a note saying, I checked my answer, it looks like from the graph the answer should be 8, but I have 12, I can't find my mistake, but I know I'm wrong. If you write me a note telling me that you checked and you know you're wrong, you will get more partial credit than if you don't tell me you know you're wrong. Now, of course, that statement about more partial credit is in a class where I'm actually grading your tests. Some of you are going to be watching this video where the tests are graded by a computer. The test is graded by a computer. There is no partial credit. It's either right or wrong. But if I'm grading the test, more partial credit if you can tell me you know you're wrong. Okay, that's this one. Zoom out a little bit. And on to the next problem. Let's hit focus there. Okay, same instructions as before. Again, remember, test, it's likely just to say solve. Now, here's one of those prerequisite skills. So, my steps that I had back over here. Note any restrictions, we'll do that. Clear parentheses, clear fractions by multiplying both sides by the common denominator, factor denominators first. And this is the first time we've seen that. So this right here, we need to factor that first. And again, if you don't remember to factor, I have some videos posted, and you can look for videos online about how to factor, depending on how the COVID response is going. So that's why I'm making all these videos, because who knows what's going to happen with the COVID. But if I'm having office hours, you can come see me. We can figure out something to help with factoring. But we need to factor this first here. And so that's going to be 6 over x plus 3 minus 5 over x minus 2 equals negative 25. And then some basics here. We need the first terms in each one of the parentheses to multiply to be x. So x and x. We need the last terms to multiply to be negative 6. But when I do a FOIL with the outside and inside, I have to come up with that x in the middle there. So things that multiply to be negative 6 would be plus 3 minus 2. And then when I check that, so this is checking the factoring. On the outside, I get negative 2x. On the inside, I get 3x. Negative 2x plus 3x is x, which is the center I want. So there's my factoring. And once I have it factored, I can see that my restrictions from the x plus 3, if you can't see it, just take that denominator, set it equal to 0. So from the x plus 3, I'm going to get a restriction of negative 3. And for the x minus 2, you can just set that equal to 0 and see what you get. And so I get negative 3, and 2. So my restrictions are x equal negative 3, x equal 2. And so there's letter A. I should have done that down here, but I didn't. My restrictions for letter A, x equal negative 3 and 2. Okay, we'll end the video here with the restrictions, and on the next video, we'll actually solve the equation.